6.1.4 tangent and cotangent graphs. So recall from our unit circle that we know the tangent of theta is equal to the sine of theta divided by the cosine of theta. And so we've already talked about rational functions. We talked about our reciprocal functions for sine and also for cosine. And so we know that whenever we have 0 in our denominator, we're going to get our graph undefined, which means that we have asymptotes there. So whenever, in this case, cosine of theta is equal to 0, we're going to get these asymptotes on our graph. And so we're going to first look at our graph y equals the tangent of x. So we'll talk about this in just a minute, but the period of the tangent graph is pi, which we'll see when we graph this. And so remember, to find your key points, it's always the period and you divide it into 4 equal parts. So that still holds true. So this is going to be pi over 4. So on my graph, I'm going to count by pi over 4. So this is 1 pi over 4. 2 pi over 4 is pi over 2. Then we have 3 pi over 4. 4 pi over 4 is just pi. 5 pi over 4. 6 pi over 4 is 3 pi over 2. 7 pi over 4. And then 8 pi over 4 would be 2 pi. So we can also go, of course, backwards. So negative pi over 4. Negative pi over 2. Negative 3 pi over 4. Negative pi. Negative 5 pi over 4. Negative 3 pi over 2. Negative 7 pi over 4. And negative 2 pi. So let's go ahead and take a look at our unit circle that we have over here. So we know that this starts at 0 radians, because we're going to think about this in terms of radians. And then up here we have pi over 2. And then we have pi radians and 3 pi over 2. And then, of course, back to 2 pi. So on my graph, when I'm thinking about sine over cosine, we know that at 0, if I think about my sine over cosine, because remember, cosine is the x-coordinate and sine is the y-coordinate. So in this case, if I have cosine over sine, I know that at 0, sorry, I said that backwards, sine over cosine. So I have 0 over 1 for this first part right here. So 0 over 1, we know would just be equal to 0. So that tells me that at 0, I have 0. And so, of course, that's going to be the same thing for 2 pi as well. And then, of course, that would be the same for negative 2 pi. Well, where else do we have 0 over 1? Also at pi. So if I go to pi and negative pi. So now let's go ahead and take a look. I'm going to use a different color here. So let's take a look at what happens at pi over 4. That's another point we like. So at pi over 4, because that's one of our key points, because we took the period and divided it into 4 equal parts, we know that this x and y for cosine and sine, we have roots 2 over 2 comma roots 2 over 2. And we talked about why when you divide sine over cosine, this is actually for tangent equal to a value of 1. So we know at pi over 4, it's equal to 1. Well, let's go to negative pi over 4 and look at that. Well, negative pi over 4, remember you're going the opposite direction on your unit circle would be down here. So this would be negative pi over 4. And so we would have positive x but negative y, which means the tangent here is negative 1. And we also know all students take calculus, so tangent's only positive in quadrant 1 and quadrant 3. So we knew in quadrant 4 it was going to be negative 1. So we have these 3 points now. And I'm trying to figure out, okay, where's my graph going to go after this? So we know that everywhere cosine is 0, we're going to have asymptotes. So it looks like at pi over 2, we have an asymptote because that would be sine over cosine, so 1 over 0 here. And then if we go the opposite direction, instead of saying 3 pi over 2, this would be negative pi over 2 if we're going clockwise on our unit circle. So we have at negative pi over 2 an asymptote. So now we're looking at, well, what's happening at this asymptote of x equals pi over 2. So here's where we can think about sine over cosine. You can also think about the big little concept, but let's think about sine over cosine. So what's happening here? As we're moving on our unit circle going towards pi over 2, notice that my sine is equal to a value of 1 up here, but we have 0. So that means our cosine values are getting closer and closer to 0. So I have 1 over a very small positive number. Remember, that's going to be a very large positive number. So that means my graph is actually going up towards positive infinity. Now, if we look at this direction, so if we're starting at negative pi over 4 and going towards negative pi over 2, it's going to be the same thing, except for notice that we have a negative sign values in this quadrant. So we have negative sign values over very small, getting closer to 0 cosine values. So 1 over a very small negative value is going to give me a very large negative value. So we're going to go down towards negative infinity. So this is at asymptote at x equals negative pi over 2. So notice that this is actually one complete cycle for our tangent graph. And so we can, of course, keep going. So let's look at 3 pi over 4. So where's 3 pi over 4 in my graph? Right here. And so we know that tangent's positive here because, or sorry, negative here because we have a negative cosine and a positive sine. So this would be a tangent of negative 1. I should have labeled my graph here. So this is 1 and negative 1. And we already know that pi is 0. We talked about that just a minute ago. So 5 pi over 4 is right here in my graph. So the tangent is positive in this quadrant, so it's going to be positive 1. And then, of course, at 3 pi over 2, we know we have an asymptote. So what's happening on this part of our graph, notice that our on this part of our graph, when we're in the second quadrant, we know that our tangent values are going to be negative. So when we're looking at this portion, we know this is going to go down towards negative infinity, and these values are going to go up towards positive infinity. And so you can see this is different than sine and cosine in their reciprocal graphs because we see that this graph is repeating. Instead of every single 2 pi, the distance from here to here is actually a distance of pi. Or you could look at the distance from here to here. So this would be 2 cycles on my graph, which is why the period for tangent is equal to pi and not 2 pi. So the first cycle actually occurs from negative pi over 2 to pi over 2. So we don't usually graph a half cycle. That's why we start from negative pi over 2 to pi over 2, because otherwise you'd be missing this other portion of your graph here. And so for this, of course, I can keep repeating. So it's 7 pi over 4. Now I'm in the fourth quadrant, so we know this is negative 1 and 0, and this would go down. And if I completed my other values, I would have another point here. There would be another asymptote right here, even though we just didn't write our key points. And my graph would be going up this way. So same thing on the negative side of our graph. At negative 3 pi over 4, we would be at 1. This would be negative 1, and we know I have an asymptote at negative 3 pi over 2. And again, we're just repeating the values that we had before, so we know this part of our graph goes up, this part goes down, and same thing, at negative 2 pi we had 0, negative 7 pi over 4 would be 1, so this part of my graph would go up. And of course, if I wanted to, I could finish, this would be at negative 1, and there would be another asymptote there. But as you can see, this is our graph. So for our graph here, you can see that your domain is going to be all real numbers except for where you have your asymptotes, which the first asymptote that we have starts at pi over 2. So the first asymptote we have is pi over 2, and then you can see that the distance from here to here is the distance of the period, which is pi. So now we add the period of our graph. So our domain is going to be all real numbers, not equal to pi over 2 plus the period, which is pi n. Unlike the secant and cosecant where we add half the period, now we're just adding the period. And our range, notice we go from negative infinity to positive infinity, so our range is all real numbers, negative infinity to positive infinity. And our tangent graph, notice it has symmetry with respect to the origin. So because of that, we know that the tangent graph is going to be an odd function. And so since it's an odd function, that tells us that's the tangent of, oops, so the tangent of negative x is equal to the negative tangent of x, which we already knew that identity from before, but that's where it comes from. So what would change these horizontal asymptotes on my graph if I were to move my graph left or right, or if I were to horizontally stretch or shrink it? So of course that would be for horizontal movements. So that completes our tangent graph. Another thing that we want to keep in mind for the tangent, since our period is pi, when we are finding our b value, our new equation would be b times the period is now equal to pi. So to find the period, if we're given a graph, it would be pi over your b value, and to find your b value, I'm sorry, if you're given an equation, it'd be pi over b value. To find the equation from a graph, it would be the b value is equal to pi divided by the period. So again, make sure you keep in mind that we've changed the equation because we know sine and cosine are b times the period equals 2 pi. Same thing for their reciprocals, but tangent is different. So let's go ahead now that we're done with the tangent graph and take a look at the cotangent graph. So cotangent graph is similar to the tangent graph, except for it'll look a little bit different, which we'll see. So we know that cotangent is 1 over the tangent, and we're using actually t instead of theta this time, so I'll put a t there, which is cosine over sine. So that means that we're going to now have vertical asymptotes everywhere where tangent or sine are equal to 0. So tangent t wherever that's equal to 0, or if it helps you on the unit circle where the sine of t is equal to 0. So we know that just like tangent, the period for our cotangent is going to be pi, since it's reciprocal, which means our key points are going again by pi over 4. So let's go ahead and put those on our graph. So we have 1 pi over 4, 2 pi over 4 is pi over 2, 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4, and then we have 6 pi over 4 is 3 pi over 2, 7 pi over 4, and 8 pi over 4 is 2 pi, and we're going to do that on the negative side too. Okay. And so this would be 1 and negative 1. So for our graph, you can graph this thinking about how cosine over sine is what we're looking at now. So basically everywhere sine is equal to 0, we know that we're going to have asymptotes. So we could go ahead and look at that. You could also graph it by graphing the tangent graph and then making the transformations, if that helps too. So two different ways of looking at this. So I'm going to go ahead and graph our tangent graph first, just so we can take a look at what it looks like. So I'm going to graph this in red. So we know we have an asymptote at negative pi over 2 and pi over 2. And our tangent graph starts at 0. 1, this one would be negative 1, and we know our graph goes up. Okay, so I'm going to group all that together. So here's my tangent graph. So we know everywhere tangent is 0, we're going to have an asymptote. So that means I'm going to have an asymptote right here. And also, again, I always like to think about it as cosine over sine because it's a lot easier to remember where the sine is equal to 0 rather than tangent. But I know the next place that we get sine equal to 0, because remember that's your y coordinate, is at pi. So at pi over 4, your sine and your cosine are both still positive, so that means I'm still staying at this point up here. At pi over 2, now you've switched. So instead of being undefined, think about your cosine over sine now. So at pi over 2, cosine is 0, sine is 1, so that means this is now 0. And at 3 pi over 4, we said that the tangent was -1, so your cotangent is also -1. So now we're looking at the other side of our graph. So still, on this part, as from pi over 4 getting closer to 0, so now we're going this way on our circle. So let me do that with a different color. So this way, we know that now our cosine values are approaching 1 and sine is approaching 0. So 1 over a very small positive number is going to be going to positive infinity. So we know now our graph is going to go up this way. And then from 3 pi over 4 to pi, so 3 pi over 4 to pi, so again, same thing. Now we're doing cosine over sine. So -1 over a very small positive value for sine means that we're going to be going towards negative infinity. So this right here would be the first wavelength of my cotangent graph, and I'm going to go ahead and get rid of the other pieces that are actually the tangent graph because those really aren't there. So that is what my cotangent graph looks like. And like you said, you can use your tangent graph to help you, or a lot of times I just like to think about sine and cosine. It's a little bit easier. So then at 5 pi over 4, we know that 5 pi over 4, which is here on my unit circle, we have a positive value of 1. At 3 pi over 2, again, cosine over sine would be 0 over -1, so 0. 7 pi over 4 is down in the fourth quadrant, so that's a tangent or cotangent value of -1. And at 2 pi, again, cosine over sine is undefined because we would get 0 in the denominator, so this would be the second wavelength. And if we go in the negative direction, so we're just going to be repeating. So that means at -pi, I have an asymptote, and also at -2 pi. And so at -pi over 2 would be 0. -3 pi over 4 would be 1. -pi over 4 is -1. And again, our graph would just be following along our asymptotes. So same thing here. We're just repeating these values. So if it helps you to use a tangent graph and make the transformations and then go ahead from there to do the graph, that's fine. It's just kind of a preference thing. Usually if we're doing transformations, it's a lot easier to use the tangent graph first. So our domain now is all real numbers not equal to, well, where's the first place we have an asymptote? It's at x equals 0. What's the distance between each asymptote, which is the period, which is pi. So all real numbers not equal to 0 plus pi times n, where n is an integer. Your range is still all real numbers, -infinity to infinity. And so now the first cycle is slightly different. It occurs from 0 to pi. So on that interval, of course, not including 0 and pi because there are asymptotes there. So for this, again, we know we're using y equals the cotangent of x. And so if we had our b value there, which would be y equals the cotangent of bx, and we were doing horizontal transformations, it's the same as tangent. So b times the period is now equal to pi instead of 2 pi. So kind of keep that in mind as you're doing these graphs. And so because of this, we can, do some other things, but we'll talk about this later. So this is our cotangent graph, and this is our tangent graph. So again, the key points to keep in mind are that the key points have changed, and also the period has changed to pi, which changes this equation. So that will do it for this, and we'll go ahead and do some more practice in class.